So for this circuit we have to find the three node voltages V1, V2 and V3. V1 here, V2 here and V3 here. This is a current dependent voltage source, and this one is a uh, voltage dependent current source, and the voltage V0 here is this drop V0 across this 1 ohms resistance, and this current I0 is actually this current, the controlling current here, which is I0. The real current is here, I0, through this 4 ohms resistance. So before proceeding to find the node voltages, uh, what we can see here is V2 should be V1 plus 4I0 and 4I0. So I0 will be, I0 is V3 over 4, V3 over 4. Now V3 can be written as V0. First let's write what is V0. V0 is V1 minus V3. So V3 can be written as V1 minus V0. So if that can be done, instead of V3, I0 is V1 minus V0 over 4, or 4I0. We will need 4I0 because this is 4I0. 4I0 is V1 minus V0. Again V2 is V1 plus 4I0. So V2 is V1 plus V1 minus V0, because 4I0 is V1 minus V0, so that's 2V1 minus V0. So we have V2 in terms of V1 and V0, and we have V3 in terms of V1 and V0. So that is done. Now we can proceed. So what we can do, first we can write KCL for this node, and this is actually will be a super node, this one. So first this entering current 1 amps, so 1 amps, sorry, that, so minus 1, because it's entering, I'm trying to write the leaving current as positives. So V1 over 4, this current, plus V1 over 4, then this current will be V1 minus V3 over 1, or it can be directly written V0 over 1. So plus V0 over 1, or just V0, and then this current will be V2 over 1, but V2 is 2V1 minus V0, so plus 2V1 minus V0 over 1, and finally this current is again entering, so that is minus 2V0. Minus 2V0 is equal to 0. So now multiplying both sides by 4, we get minus 4 here, plus V1 plus 4V0 plus 8V1 minus 4V0 minus 8V0 is equal to 0. So that will be V1, that will be 9V1 minus 8V0, this one and this one getting cancelled, 8V0 is equal to 4. So this is our equation 1. Now we can write KCL for V3, node V3. There will be 3 currents, this one, 4 actually, this one, this one, this one and this one. So this current is 2V0, so that is a positive current, 2V0, because it's leaving current. And then this current will be V3 minus V1 over 1, that is minus V0 basically. So minus V0 over 1, let's just write the 1 for the time being, and then this current, which is I0, that will be V3 over 4, but we know I0 is V1 minus V0 over 4, so plus V1 minus V0 over 4, because that's I0, we have done it here. And then finally this current, which will be V1 minus V0, which is V3, minus 10 over 2, this is 10 volts, so V1 plus V1 minus V0 minus 10 over 2, so this is this current. So now again for this one, multiplying by 4 both sides, we get, first let's do this one, so this is just V0 plus V1 minus V0 over 4 plus V1 minus V0 minus 10 over 2 is equal to 0. So this is 10 actually. So multiplying both sides by 4, 4v naught plus 2v1 minus 2v naught plus 2v1 minus 2v naught minus 20 is equal to 0. Sorry, this one will be just v1 here because it's 4 already there, so like that. So there was 4, so when multiplied by 4 it will be just v1 minus v naught. So we are getting here 3v1 minus this one and plus v naught is equal to 20, or v naught is 20 minus 3v1. That is what we are getting as equation 2. So we can replace v naught by v1 in equation 1. So 9v1, so let's write it again. 9v1 minus 8v naught is equal to 4. So 9v1 minus 8, and this is 20 minus 3v1 is equal to 4, because v naught is 20 minus 3v1. So it's 9v1 minus 160 plus 24v1 is equal to 4, or 33v1 is equal to 164, and that's v1 is equal to 4.97 volts. So that is the value of v1. Now we need to find v naught first before we can find v2 or v3. So v naught will be 20 minus 3v1, which is 20 minus 3 into 4.97, that's 5.09 volts. That's there. So v2 will be v3 will be v1 minus v naught, which is 4.97 minus 5.09 volts. So that is minus 0.12 volts. That's v3. And v2 is, if we go back there, we have v2 as 2v1 minus v naught there. So 2v1 minus v naught, so 2 times 4.97 minus 5.09, and that is 4.85 volts. So that is v2. So we have all three voltages, v1, v2 and v3.